Okay, so the first method we're going to talk about is electrolysis. Already done this in detail on a video, so I'm not going to ramble on too long. Just remember, electrolysis is the use of electricity to split up an ionic compound, and you're going to use it on all metals more reactive than carbon. It will work on every ionic compound, but you only use it on the ones more reactive than carbon because it's very expensive. So you only use it when you have to use it, as opposed to just using it all of the time, because it is very expensive. Okay. Electrolysis, you're using electricity to split something up. Ionic compounds only conduct electricity when they are aqueous, which means dissolved in water, or molten, which means you have melted them. So aqueous or molten. The reason being is that the ions, you have to use that word ions need to be free to move, and ions are not free to move in a solid. So really common exam questions about electrolysis is, what do you have to do to a solid ionic compound to get electrolysis to work? To get it to work, you need to dissolve it in water or melt it, because when it's solid, the ions can't move, and when it's aqueous or molten, the ions are free to move. So that's a really, really common exam question. Once you've got your ionic compound in liquid form, you're going to pass an electrical current through it, and that will cause the ions to split up. You're going to have a positive side of your battery. You're going to have a negative side of your battery. Positive side, panic, is called the anode. Negative side is called the cathode. And if I was splitting up a ionic compound, say for example sodium chloride, sodium is my metal, chlorine in there is my non-metal. If I were to split up sodium chloride, we know that metals lose electrons, and when they do, they form positive ions. Okay, sodium's in group 1, it forms an ion with a +1 charge. Chlorine is in group 7, it forms an ion with a -1 charge. So if I have sodium chloride, it splits up into Na plus and Cl minus. Those Na plus ions are going to go to the cathode, because opposite charges attract. Those Cl minus ions are going to go to the anode. Those negative ions attract. If you need further help on predicting the products at the anode and the cathode, then watch my other video, which I'll also post, because I go through loads and loads and loads of examples. But essentially, electrolysis, all metals more reactive than carbon, you use electricity to split it up. The positive metal always goes to the cathode. Okay, the metal is always the first word in the name, and the metal always goes to the cathode. The non-metal is always the second word in the name, and that always goes to the anode. Okay, the thing you have to look out for when you're predicting these products is that if you've got it in aqueous form, so if you've dissolved it in water, then you also have water present, and water contains hydrogen, and it also contains oxygen, and that will affect the products that you get formed at the anode and at the cathode. The general rule is, if your ionic compound is aqueous, so if I had sodium chloride aqueous, if the metal is not copper, and in this case the metal is sodium, so the metal is not copper, that means copper is going to, if the metal is not copper, and in this case it's not, that means hydrogen will form at the cathode, and at the anode it's the same as what we had above. You've got chlorine forming at the anode. Okay. Again, if you need more detail on this, there's another video that I'm going to post to you, because I've done a million examples of them already. Other method, okay, that we use on all of the metals less reactive than carbon is called reduction with carbon. All that means is that you heat the ionic compound. So if I take iron oxide, you heat it with carbon, and because carbon is more reactive than the metal, they're going to swap places. And when they swap places, you are going to get carbon dioxide, and you're going to get iron left by itself. So by heating it with carbon, you end up with the pure metal by itself. And this will work on every metal compound as long as the metal is less reactive than carbon. And I get carbon dioxide and I get zinc. Okay, so that worked on iron, it worked on zinc, it will work on copper. You don't need to use it on silver and gold because they're already pure metals. It's not going to work, okay? This equation will not work on any metal more reactive than carbon. So there is, you can't use it, you'd have to use electrolysis instead. We call this method reduction with carbon. Just to remind you, reduction is the removal of oxygen. And what you will see in these equations is that iron on the left-hand side has oxygen, iron oxide. Iron is bonded to oxygen on the left-hand side, but on the right-hand side, iron is no longer bonded to oxygen. Okay, so we've had reduction, we've had the removal of oxygen, and carbon is the element that's done this. So you're using carbon to remove oxygen. So I can say that the iron oxide has been reduced. So iron oxide on the left going to iron on the right, iron oxide has been reduced. In the equation underneath, zinc has oxygen on the left, it doesn't have oxygen on the right, zinc oxide has been reduced. The oxygen has been removed from zinc oxide to just give me zinc. So in equation 1, iron oxide reduced, equation 2, zinc oxide reduced, and it's carbon that is doing this. That's pretty much all I need to know about reduction with carbon. The last two methods of extraction are biological methods of extraction. They are called phytomining and bioleaching. They are the biological methods of extraction because in phytomining you are using plants and in bioleaching you are using bacteria. Now, I've outlined the details of these methods in your chemistry booklet, so I'm not going to go through it all again here because it's mostly just reading. The most common exam questions on phytomining and bioleaching is they just want advantages and they want disadvantages. Okay, disadvantage of both, they are slow. Both of them are slow methods. It's going to take a lot of time. Another disadvantage, particularly of phytomining, everyone assumes it's going to be really cheap because you're using plants to extract the metal. It's actually quite expensive because of the amount of people you have to employ. You have to plant loads of trees and then you need to take care of the trees and you need to cut them down, you need to harvest it, and you actually employ quite a lot of people to do this. So phytomining is quite expensive. And another disadvantage, though, of both methods is that they're both quite toxic for the environment. You might think that plants is good for the environment, but you have to burn the trees afterwards, so they can both release toxic chemicals into the environment. Again, for more details on this, look in your chemistry booklet. Advantages of both of these processes, they have the same advantage. They allow you to use low-grade ores. So ores that you wouldn't normally use because it would be too expensive. Ores that you just wouldn't normally use because it's difficult to extract the metal from the ore. They're called low-grade ores. You can use those ores with these techniques, and that means that you need to do less mining. Remember, we're getting metals from deep down in the Earth's crust. In order to get there, you're going to have to dig right down. You're going to have to create mines. Mines are dangerous. They're not a very nice place to work. They're also unsightly. So anything that you can do that reduces the amount of mining is going to be a positive. It's going to be an advantage. So more information on these two techniques, look in your chemistry booklet. The biological methods, phytomining uses plants, bioleaching uses bacteria. They're both slow, but they allow the use of low-grade ores. This reduces the amount of mining that needs to take place. I've attached a question sheet. I want you to have a go at those questions now. Do them by yourself. I'm going to post another video where I go through the answers. Don't just look at the answers. It's a waste of your time. Do the questions by yourself. And then once you've got them done, or you've attempted all of them at least, then tune into the next video and you can see me going through all of the answers.